Module 2, Kubernetes architecture and its components. So Kubernetes cluster architecture. Let us have a brief, like, what are we going to discuss in this entire module? So the first thing would be Kubernetes architecture. Number two, it would be Kube API server. And number three, Kube or HCD, which is a cluster memory, ETCD. So we call it as HCD. It is a brain of the cluster, just like it stores everything, the memory of the cluster. And number four, it is Kube scheduler. And number five, Kube controller manager. And number six, it is kubelet. Number seven, Kube proxy. So this is for networking. And later on, if time permits, we'll also discuss the actual container runtime. So these are the 8 things we are going to focus in this module: Kubernetes architecture and the component that we have written down here. So let's start with the first one. And in this module, we are going to go deeper, and we are going to look inside the cluster itself at the components that make Kubernetes work, uh, and watch what each node or what each component does and how they talk to each other. So by the end of this module, you will understand not just how to use Kubernetes, but what is actually happening when you run any kubectl command, right? So we start at the front door. The front door in Kubernetes is the Kube API server, and uh, walk, work our way through every component in order, actually. So each one connects to the next one. It's like, what are the modules I have written here? So each one connects to the next one. So when we reach the end, you will have a complete understanding of the entire Kubernetes system, right? So throughout this module, I am going to draw some comparisons to middleware components you already know. And just like, Kube API server, let us take an example of uh, a WebSphere deployment manager, which behaves like a Kube API server. And HCD behaves like a WebLogic domain configuration. So in WebLogic domain, the main configuration file is config.xml. So it contains all the information about your WebLogic domain. So HCD is the memory in Kubernetes, right? So it behaves the same way. And if you talk about kubelet, it is equivalent to the node agent in uh, or in WebSphere, actually, not WebLogic, but in WebSphere, there is a component called node agent, which is responsible to talk to the admin server and synchronize the changes with the local configuration of the node. So these are the simple comparisons I'll just use. They are not perfect, but yes, to align with middleware, right? So to start with Kubernetes architecture, the first one, Every time I sit with a new team that is adapting Kubernetes, the first thing I draw is this overview. It is not about YAML files, the manifests we use in Kubernetes. It is not about the commands. It is just a picture of what the Kubernetes cluster actually looks like. So I do this because people who try to learn Kubernetes by memorizing the commands without understanding the architecture will end up confused. Every time something you know does not behave the way they expect. So it is very important to understand all the architecture and the components, because then only you would be able to expect the Kubernetes behavior, the logs, and what exactly Kubernetes is trying to tell you whenever there is a deviation when you apply any command, right? So a Kubernetes cluster is made of two types of machines. One is the control plane, and the other one is worker node. So these are the two machines. Number one, control plane. With the name itself, you can determine what it does, control and worker. So this is a command center. Everything is controlled by the control plane, and worker node is a labor, or it is a worker actually. So the control plane makes all the decisions, and the worker node or worker nodes, you can have multiple worker nodes that do the actual work of running your containers, right? So they communicate constantly to keep the cluster in the state you declared. So it makes control plane makes all the decisions. And worker, this one, it does the actual work, meaning running the container. So this is important. So control plane takes the decisions about your cluster. So what kind of decisions it takes, we'll discuss. And worker node is where actual containers are created and run. So these are the two important things, the basic things we need to know. The control plane decides what to run and where to run. This is a decision. And worker nodes run it and report back. So all communication flows through a single entry point called API server. So it is what to run and where to run. So this one decides the major decisions, what you want to run. You want to run a deployment or a replica set or a service, or you want to roll out an update. So that is what. And where there may be multiple nodes. There may be 10 nodes, worker nodes. So where you want any object, a particular deployment, or to run on a container, where you want to place the container. So these are the two important decisions that is taken by control plane, right? So there may be multiple worker nodes, right? So these nodes here, the actual containers run, they get created and they start running your application. And this worker node communicates with, okay. Let me put it here. So this is your control plane, and there are multiple worker nodes. This is a worker node, and this is another worker node where actual uh, pods run. There is a pod here, there is a pod here, there is no pod here. So you send a command kubectl apply, so apply a deployment, right? So the command, it goes and gets stored in the component called etcd, and a scheduler, the kube scheduler, is responsible to take a decision where container should be created, on which worker node it should be created. It is a job of a kube scheduler. So these all things, actually this command does not go directly to control plane. So there will be a kube API server. So the communication, everything goes through kube API server. And these worker nodes also talk to API server. So everything in the cluster talk to other component via API server. So one thumb rule to remember: no direct communication. No direct communication except through what? Through API server.